6.1 Perpendicular and angle bisectors. Essential question. Can I find the measures when given a perpendicular bisector? Can I find measures in distance relationships given an angle bisector? Let's start with a word equidistant. Equidistant means that it's going to be the same distance. So point P, we say, is equidistant to A and equidistant to B, especially when it lies on the perpendicular bisector. We're going to use this word in the following theorem. Perpendicular bisector theorem. If a point, and in this case it's C, lies on the perpendicular bisector, which it does, here's the perpendicular bisector, I'm making a perpendicular, I have a bisector, then what we say is this distance, CA, is the same distance as CB. So it's equidistant to the endpoints of the segment. The converse is also true. If you find that a point is equidistant, like this one, equidistant to A and equidistant to B, then that point D must lie on the perpendicular bisector. So that perpendicular bisector will include the letter D. Now here's the proof. A perpendicular bisector creates two right triangles. When it creates two right triangles, we're going to get two angles. So we're going to have an angle pair. Because it's a bisector, that's a midpoint, we're going to get a pair of sides that are congruent. And so here's our pair of sides from our midpoint. We're also going to get a reflexive, which we're going to get here, our side. And so the triangles will be congruent by side angle side. Once the triangles are congruent, then we can say by corresponding parts that CA is congruent to CB. And when they're congruent, we know by definition of congruence that their distances are equal. All right, let's go ahead and utilize this in a problem. Right now I see a perpendicular bisector. So I know I have a perpendicular bisector. Once I know I have a perpendicular bisector, anything on the perpendicular bisector is equidistant to the endpoints. These are the endpoints. So that's going to tell me that SR, or RS, is going to be the same distance, which is 6.8. All right, let's take a look at this problem. In this problem, we are given that H is equidistant to the endpoints. These are the endpoints right here, G and E. So when I see 2 points that are equidistant to the endpoints, then I know that H lies on the perpendicular bisector. So I know that this is going to be a midpoint, which is going to allow me to say that EF is 9.5, and therefore EG, from E all the way to G, will be 19. All right, I see a perpendicular bisector again, and we know that whenever we see a perpendicular bisector, any point on it is going to be equidistant to the endpoints. Here are the endpoints, equidistant. So that's why I'm going to set 3x plus 14 equal to 5x. 2x will be equal to 14, therefore x is equal to 7. Now we want to find AD, and therefore AD will be equal to 5x, and if I put the 7 in there, I'm going to get 35. Okay, now it's your turn. Go ahead and stop the screencast, see if you can do these problems, and then restart the screencast. Now here are the answers. I saw perpendicular bisector, so I knew I had some equidistant. And number 2, again, I saw perpendicular bisector, so I knew I had some equidistant. Number 3, number 3 is different. It's the converse. I know that this is 20.4 and this is 20.4. So I know that Z is equidistant to the endpoints. So I know that Z must lie on the perpendicular bisector, which means if this whole thing is 14.8, then from here to here, that's been bisected, this would be 7.5. Okay, angle bisectors. This is an angle bisector. AD is an angle bisector. And this point right here, D, has a distance to one side and it has a distance to the other side. Remember, distance from a point is always perpendicular to the line. Okay, this is what the angle bisector theorem states. It says if you have an angle bisector any point on the angle bisector is equidistant to the sides. So this distance and this distance will be the same. And why is that? Well, because these two triangles can be congruent by angle, angle, side, this reflexive side, angle, angle, side. And once the triangles are congruent, we can get this by corresponding parts of congruent triangles are congruent. And once we have congruence, we have equality. The converse is also true. If you see these distances being the same, if this point D has the same distance to each side, then it must lie on the angle bisector. All right, let's take a look at these problems right here. Now, I see this perpendicular, so perpendicular means I have a distance, and I notice that the same numbers, so I know I have equidistant to the sides. As soon as that is established, that it's equidistant to the side, then J must lie on what we call the angle bisector. So I know that if this is 42, this is 42 degrees, and the measure of angle GFJ is 42 degrees. Okay, let's go ahead and find RS. Now I see an angle bisector, and I know any point on the angle bisector is equidistant to the side. So I know these distances will be the same. I'm going to write 5x equals 6x minus 5. So x will be equal to 5. I want to find RS, and RS is 6x minus 5. I put a 5 in there, I'm going to get 30 minus 5, and the answer will be 25. Okay, here's some problems for you to practice. Go ahead and stop the screencast and see what you can do. Here are the answers. I saw an angle bisector, so I know I had equidistant. I saw an angle bisector, so I know I had equidistant. And on number 6, I saw that this was AD was going to be 3.2, and this was going to be 3.2, and because these are perpendicular, I knew that D is going to lie on the angle bisector. And since this was 39 degrees, I know that the measure of angle ABC will be equal to 78 degrees because it's going to be double this number. Okay, here's a situation. A goalie is in a path where these two angles are going to be congruent. Let's go ahead and make them a darker color. This angle and this angle are congruent. Will the goalie have to move farther to block a shot toward the right post or to the left post? And the answer is they're going to be the same distance because the goalie lies on the angle bisector. So that means it has the same distance to each of the sides of the triangle. So it really doesn't matter which goalpost, the same distance. Okay, here's a little summary of what we've been doing so far. Stop the screencast and see if you can fill in the blanks. Okay, here are the blanks. If you can say that something lies on the perpendicular bisector, then it's equidistant to the endpoints. And the converse, if something's equidistant to the endpoints, then it must lie in the perpendicular bisector. If a point lies on the angle bisector, then it is equidistant to the sides. And if a point is equidistant to the sides of an angle, then it lies on the angle bisector. All right, write an equation of a perpendicular bisector of the segment. I've been asking you to do this quite a bit. Here is another summary. Remember, bisector means you're going to have to work with a midpoint. And so the first thing I do here is try to get the midpoint, and here's my midpoint. Now I want a perpendicular, so the first thing I try to do is find the slope of PQ. I find the slope of PQ, but the slope of the perpendicular will be the opposite reciprocal. So I go ahead and use the slope that I want, which is this one, and I use my midpoint, and I go ahead and put it in point slope form. And this form is fine with me, but if you want to simplify it, then it'll match this answer that they're showing right now. Okay, here's an opportunity for you to take a look at 2 questions, stop the screencast, see what you can do, and then restart to see the answer. And here's the answer. The answer is no. We can't conclude that this is an angle bisector because PS and SR are not considered distances unless we see a perpendicular. So if we don't see a perpendicular, we can't say equidistant. Even though it shows these lengths are the same, they're just lengths. They're not distances. And if you tried this perpendicular bisector again, you would have gotten this answer right here. And you can simplify it if you wish. And this is the end of the screencast.